Hi, hello everyone. Today's topic is bonding in coordination compounds using VB theory. So here we are going to see bonding in complex compounds or coordination compounds using VB theory, that is valence bond theory, the similar theory which we have studied in chemical bonding. Now let me give you a gist of it. According to this theory, the metal atom or ions under the influence of ligand. So under the influence of ligand, the metal atoms or ions, they will use their n-1d ns-np, either this set or ns-np-nd, this set of orbitals for hybridization to give a new set of equivalent orbitals, which are called as hybrid orbitals of definite geometry, such as octahedral, tetrahedral, square planar, etc. Now, what happens? These hybrid orbitals are allowed to overlap with the filled vacant, not vacant, filled orbitals of ligand. Means vacant hybrid orbitals then overlap with the filled orbitals of ligand, and we can say that ligands are donating the electron pairs in the bonding, and a coordinate bond is formed. So we have CMI, which is having vacant orbital, and we have ligand which are having filled orbital. So what happens? Ligand donates the electron pair to CMI, and a coordinate bond is formed. So a lot of uh, a lot of types of hybridization happens here. Like for example, for coordination number 4, we have sp3, dsp2, or d3s hybridization. For sp3, we have shapes like tetrahedral, and for coordination number 5, we have, for example, we have hybridization sp3d. For coordination number 6, we have hybridization sp3d2 or d2sp3. For coordination number 5, we can say the geometry will be trigonal bipyramidal, and here the geometry will be octahedral. So now let me explain you this theory with the help of the example. For example, we are having CONH3 whole 6 plus 3. We already know that cobalt is having 3d7 4s2 configuration. So cobalt plus 3 will have 3d6. So it will be d6 type of configuration. Now, when we see CO plus 3, we are having 1, 2, 3, 4, 5, 6. This is 3d. Then we are having 4s, and then we are having 4p. So this is the electronic configuration of CO plus 3. But when we see CO plus 3 in CONH3 whole 6 in this complex, so under the influence of the ligand, what happens is these electrons in the d orbitals, they pair up, and we get like this, the pattern like this, and then we get two vacant 3d orbitals, one 4s we already have, and 4p we already have. So two d orbitals we are having, and 1s and 3p. So we are getting d2sp3 hybridization. So the n minus 1d d orbitals, ns and np. So the first set which we have studied, n minus 1d, ns or np. These orbitals undergo hybridization and they form hybrid orbitals. How they will form? So 6, 1, 2, 3, 4, 5, 6 orbitals are used. So 6 new hybrid orbitals are formed. So now what happens, six in these 6 hybrid orbitals, suppose NH3 is donating the pair of electron to one orbital, then it will donate to the second, means the second NH3 will donate to second orbital, and this process continues. So all 6 NH3 will donate pair of electron to all 6 hybrid orbitals like this. So we will have electrons like this filled in the hybrid orbital. So what happens is the inner d orbitals are used, and you can see there is no unpaired electron. So we also call this complex as inner orbital complex. We call it inner orbital complex, or we also call it uh, low spin or spin paired complex, low spin or spin paired complex. All right. Now, because there is no unpaired electrons, so this is dimagnetic. So let me give you the orbital picture of this. What happens is under the influence of the ligand, this cobalt will make available 6 this hybrid orbital, vacant orbital, which are hybrid orbital like this. All right. Now they will make a definite geometry. You can see octahedral type of geometry is obtained over here. Now what happens? Ammonia's filled orbital will axially overlap with these hybrid orbitals like this. So this is actually the theory. What happens like this? So this acquires a definite geometry. If we'll make diagrammatic representation, you can see like this NH3, NH3, one more ligand NH3, like this, and this way. So you will get a definite geometry which is octahedral shape. So what happens under the influence of the ligand? These uh, pairing will happen, and then hybridization will happen, and then ligands will axially overlap with the hybrid orbitals, and this particular complexes are formed. Let me give you one more example. COF6 3 minus. So here also we can see CO is in +3 oxidation state, that is D6. So when we see, we observe that, see, suppose this is 3D, this is 4S, this is 4P, and we have 4D also. So how the electronic configuration is 1, 2, 3, 4, 5, and 6. Now under the influence of fluoride ion, they will not pair up. Okay, so as they are not pairing up, what is going to happen? One second, 1, 2, 3, 4, 5. Yes, they're not pairing up. So what is going to happen is we will see that it will use the outer d orbitals, these two. So S, 1, 2, 3, P, and these two are D. So we are getting sp3d2 hybridization. What we are getting? sp3d2 hybridization, because inner D cannot be used. They are filled and they are not getting paired. So one, you can see, one second, 1, 2, 3, 4, 5 orbitals. Let me draw it again like this. One second. 1, 2, 3, 4, 5, and 6. So you can see these 6 orbitals are filled and they are not getting paired. So these 6 orbitals are filled and the electrons are not getting paired. So we will use the outer d orbitals now. So it will now these 6 orbitals with the outer d orbitals will go into hybridization, and 6 hybrid orbitals are formed of equal energy like this. So now fluoride ion, all 6 fluoride ion will donate the pair of electrons like this, and now they are paired like this. So this way, now you can see here there are unpaired electrons. So because unpaired electrons are present, so we can say this complex is paramagnetic. Also because outer D is used, so we will say it is outer orbital complex, outer orbital complex, or we will also say it high spin or spin-free complex. So this way, how valence bond theory is applied in coordination compounds, you can see under the influence of fluoride ion, they are not getting paired, and under the influence of ammonia, they are getting paired. And here also we'll get the same type of geometry, CO, F minus 1, 2, 3, 4, 5, and 6. So 6 fluoride ions are surrounding like this, and again it is forming a octahedral complex. So this is the way how VBT is applied here. Thank you so much. I hope you got it. Thank you.